Very good. All right. Number 3 type, one real zero and a cubed vector. So generic is going to be x minus alpha. This give you 1 0, which is alpha, but they have to be cubed. So you altogether have only 2 zeros right here. So let's take an example where an a is 2, and then your alpha is 1, and then your second zero is going to be 1. Sorry, negative 1. So the factor theorem gives you p1 is 0, p negative 1 is 0. That's very clear. It's gonna be concave up because 2 is greater than 0, so it's gonna look like kind of like that, right? You have 1 and negative 1, that's 0. What's gonna happen when x is 0? So 2 times negative 1 cube 1 makes it negative 2. So when you have x is 0, you have negative 2. So you're gonna have something like, you have to go up because that's generally going up, concave up. And then when you hit 1, after 1, you're gonna also hit upwards. But when you have a 0, that is repeated 3 times. Around here, it's kind of flat. Flat. Why do you think it's kind of flat around there? If you have repeated 0, why do you think it's going to be flat? Well, let me remind you the case when we had x fourth power. Okay? So, I mean, except for Vicky, all 3 of you, Julie, Boram, and Annie, you have learned the parent function, x fourth power. And then when we learn the parent function, around 0, it's more flat. Because when it's close to 0, those numbers are raised to 4th power, which means if you have numbers that is between negative 1 and 1, those numbers are multiplied more and more, repeated by themselves, it's closer to 0. So if you have 0.5, but 0 point is raised to 4th power, that's closer to 0. Okay, so it's the number gets smaller and smaller. So that's why around that number it's flat, because you raise the powers more. Okay, so what is very important here, the cubed vector x minus alpha to the to raise to 3rd power, it cuts x-axis, but it's kind of like very flat around that 0. So you have to understand the behavior of the graph. Okay, same answer here, concave up, concave down. And then how many intercepts here? Julie, how many intercepts do you see? 2. 2, very good. Because 1 is repeated 3 times, right? And then how many turning points do you see? 3. 3. Huh? 1, 2. So it's going down direction, it's going up direction. So you only have 2. 1 time of change. Turning.
Okay.
So you have 2 different directions, but there's 1 turning point, right?
Yeah.
It's very good. In life, your life was going worse, and then you hit the bottom, and then you're really sad, and then you're going up, you're happy again, right? So basically, there's only 2 directions, so you have 1 turning point. Yeah. So that is 3rd type. Can I move on, guys? No?
Yes.
Okay. So 1 linear vector raised to the 4th power. This is the easiest and the simplest form. I like it because it's very close to the parent function. So A gives you the vertical stretch or vertical compression. And then if you add or subtract something to x, that means you can move it around horizontally, and then you multiply for 4 times. So 4th power. So for instance, specifically you have A is 1 and then alpha is 2. In this case, well, you used to hit origin, but you have to move 2 steps to the right because you subtracted 2. And then I'm pretty sure when you plug 2, it's 0 because of the vector theorem. And then when you plug 0, because I'm just curious about y-intercept. So when x is 0, I have negative 2 4th power, which is 16. So I hit 16 right here. So it's going to kind of looking like that. Right? It's kind of flat around the 2. It's like flatter. And then when you have 1, just to be more accurate, 1 minus 2 4th power makes it 1. So you hit 1 and 1. right? So you are going to have a graph that kind of looks like quadratic, but it's actually quartic. So as you can see, when you have axis 2, the graph touches x-axis, but very flat, right? But it doesn't cut through it. So what happens when a is greater than 0? So many times repeated. How many x-intercepts in this case? Vicky, what do you think? How many x-intercept?
Just one.
Just one. One answer, one factor. How many turning points do you see?
One.
Very good. Okay, that was the easiest one. Can we move on to number 5? So, starting from number 5 and 6 is slightly more complicated because now we don't have real answers anymore because we covered all the cases of a real roots from type 1 to type 4. So type 5 is going to be 2 linear factors and 1 quadratic factor. So what's going to look like? It's going to look like, okay, you have something. Okay, I just don't want to have a here because I'm going to have a later. So you have alpha and beta as your factors, and then there's a 1 quadratic equation that's kind of trouble for you because you cannot factor it anymore. Because your b squared minus 4ac is less than 0 because your delta is less than 0. So you don't have real roots. So take a specific example, x minus 1 times x plus 1, for instance, to make it easier, simpler type. If I have x squared plus x plus 1, then you have b squared is 1, and then 4ac makes it negative 3, which is less than 0. So I confirm that this case we don't have real roots. So when you plug 1 and negative 1, the answer is 0. Let's see what happens when you have p0. So it's going to 0 minus 1 is 1, 0 plus 1 is 1, and then 0, 0 plus 1 is 1, so you have negative 1. So it's just easier for me to sketch the graph with some coordinates figured out. So 1 and 2, so you have 1, 0, negative 1, 0. And then when you have 0, you have negative 1. So it's going to kind of cover that. And then it's going to be generally concave up because, because A is 1 here. So it's going to be concave up. Let's figure out a little bit more. When you have negative 2 and 2, just to be a little bit more accurate. So negative 2 minus 1 makes a negative 3, and then negative 1, and then 4 plus minus 2 plus 1, that makes it 9. So you're going to hit 9 right here. Right? And then when you have 2, I can feel that it's going to be so much greater. 1 and 3, and then 4 plus 2 plus 1, about 21. It's going to go higher. I can't even sketch. I just stopped here. Right? So it's going to be generally going up, and then you only have 2 mids right here. So when you have 2 real linear factors and 1 real quadratic vector with a discriminant 0, okay, doesn't touch, you can see that. You have first intercept, x-intercept, second x-intercept, right? So altogether you have only 2 intercepts, and then seems like it's possible to have 1, 2, 3 turning points maximum. Generally, it will follow the shape of concave up or down depending on A. Okay? The last one is not having any meets. This is like a floating above x-axis or below x-axis. So for instance, you have, the general form is going to be some kind of quadratic multiplied by the second kind of quadratic. So for instance, specifically x cubed plus x plus 1, and then x squared plus x plus 2, something like that. When you sketch this, let's just take a look at it. It's going to be floating, okay? So it does not meet x-axis at all. It's floating. You can see there's nothing. So same thing. It's concave up or down depending on A. And how many x-axis? Nothing. Okay, turning point. Yeah, I can maximum have 3. All right? So shall we summarize? But before that, do you have any questions so far, guys?
No.
No? Okay, let's conclude. For quadratic polynomials in which A is the leading coefficient, if A is greater than 0, Julie, what do you think? It opens upwards or downwards?
Downward.
a is greater than 0,
Upward.
upwards. Very good. It's going to look something like that. Okay, vice versa, Julie. If a is less than 0,
Downwards.
very good. Okay, it's going to look like that. All right. Hold on. The maximum number of x-intercepts for quartic polynomials is?
4.
Very good. 4. Many cases, but this is a maximum. Hold on, go ahead. Minimum number of x-intercepts for quartic polynomials is?
1.
Minimum number. The last one. How many do you have?
0.
Right. So you have
No.
Hmm?
1.
right, 0. You just said 0. So it means it's possible to not have any x-intercepts in quartic polynomials. Okay.
Yes.
Yes. So what's going on with 4? So you have something like that, right? So that's 4
Mhm.
cases. 3 cases, when you have 3, you have something like that, right? 1, 2, 3. It touches. When you have 2, what's going to happen with the 2 cases? Well, there
2 x-intercepts.
are 2 cases. One is complex zeros are there. So one case is like something like this. So you have like flat here and going up. And then another case is when you have 2, is that you touches 2 real zeros, and then one is complex numbers like that, right? And then when you have 1, 0, that's really simple. It's just like parent function like that. And then when you have 0 cases, what happens? It's just floating around like that, right? So you have 1, 2, 3, 4, 5, 6 cases. It varies between 0 number of intercepts and then 4 number of intercepts. The last one. Graphs of quartic polynomials are always continuous and smooth curves. It's just important for calculus later. Okay, it's just good to know information. Are you okay so far, guys?
Yes.
Okay. So example 1, find the equation of the quartic with the graph. Vicky, how many roots do you see?
3.
Very good. So can I start with the type 2? 2 real zeros and 1 0 repeated. Which 0 is repeated, Vicky?
The middle one.
Right, -1. So I'm going to write down x plus 1 square because that's repeated. And I have to have some kind of a to multiply it in front of it. But a seems like greater than 0 because it's concave up, right? And then second 0 is going to be x plus 3, -3 and negative just 3. So it's x plus 3 and x minus 3. Am I done here? Vicky, am I done? What's missing?
A.
A is missing. How do you find A?
Concave up is 1.
Right, so it's concave up, but we are missing.
You find use the 0 minus 3 coordinate to
Very
find
good.
A.
Very good. 0 and -3, that's the coordinate. So I'm going to plug x as 0, and then I'm going to have -3. Let's do that. A times 0 plus 1 is 1. 0 plus 3 is 3. 0 minus 3 is 3. The -3. So what I have is -9a is -3. What is our a? What do you have to multiply there?
3 over 1.
You mean 1 over 3?
Oh yeah, 1 over 3.
A third. Very good. So a is 1 over 3. So the final answer is going to be 1 over 3 x plus 1 squared times x plus 3 x minus 3. We just found the equation. Very good, Vicky.